All right, guys. I believe this is where we left off yesterday, yes? Yeah, because we did a few and then, yep, this was the one we finished off on. We'll do one or two more of these here, and then we'll move on to the last type, the last thing that we're doing. This was the senior shirt for that year. If y'all really like this shirt, you can go beg Hopper. She's got more. She's got a whole box of them left over. Class of quarantine. All right, guys, so if we look at this here, this first problem, 6x to the fourth minus 11x cubed minus 16x squared plus 2x plus 4. With any of these here, the first place I would start is graphing. I would always start with graphing these here. Because if we can get at least two solutions, if I can get two solutions for this fourth degree polynomial, then we can use the quadratic formula from there. Because we want to get at least two solutions less than the degree. Now, if I get four solutions, we're done. That's all of them. We don't have to do anything else. So, in the graphing calculator, six x to the fourth minus 11x to the third minus 16x squared, nope, nothing there, plus 2x plus 4, plus 2x plus 4. So once we type this in and hit graph,
what would the slope even be?
So we wouldn't have a slope across the whole function, but we do have different slopes depending on the curve at those different points. Part of calculus is actually finding the change in the slope of these type of functions. No, so we won't do that. But we'll look at this here. So we do see that it crosses the axis in two spots for sure. One spot it looks like it does touch it but doesn't cross, and then we have a third. So we have two that do, and then here it looks like it touches the x-axis but doesn't cross. So we have several places that this could be. Now, if I wanted to, we can zoom in between -4 and 4, so 8, 4 and 8, graph. So at this point here, it does look like it crosses. It actually goes low enough, so we can pull it in even further, -1 to 1, so distance of 2, let's go 0.2. So it hits it, so right in here, let's say trace. So here, fill. Okay, I'm going to use the arrows because this is going to take forever with this pen. So the y value is positive, still positive, yes? Still positive. The y value just turned negative, yes? So that means it crossed. That means it crossed the x-axis. So what that's telling us is that there's actually two points over here that it does cross. We had to get very, very small to find them, but it crosses twice. Yes. And it's very nice that it can do that. So since we didn't get any nice numbers, we're going to find our rational zeros. Now, luckily for us here, the rational zeros aren't going to be as many as the last time. Because the factors we're looking at, the factors of the constant term, are the factors of 4, yes? So the factors of 4, well, we have 1 and 4 are factors of 4, and what else? 2 and 2, yes? Yes. Mm-hmm. So 2 and 2, do we write any numbers that are repeated? So it's 1, 2, and 4. Because even if we did put 2 twice, when we do the plus or minus, we don't rewrite it, so there's no point in writing it twice. The leading coefficient is 6, so we'd have 1 and 6, and 2 and 3. And again, when we start doing this here, we'll do all the factors of P over all the factors of Q. Well, the first number for Q we divide by is 1. So really all we have to do is relist the factors of P. So 1, 2, and 4, positive and negative, are possible factors. Are they actual factors? So did it cross at 1, positive 1, negative 1, positive 2, negative 2, or positive or negative 4 when we graphed it? No, it crossed at not nice numbers, so we already know that none of those are going to work because we already looked at the graph, yes? Yeah. Yes? Mm-hmm. Okay, and I'll write it down here in a little bit. So the next one we'll look at 2, so we'll have plus or minus a half. 2 divided by 2 is 1. 4 divided by 2 is 2. We have both of those. We don't have to relist them. The next one we'll look at is 3. So we'll have 1 divided by 3 is plus or minus 1/3. Then we move over to the next one. 2 divided by 3 is plus or minus 2/3. And then 4 divided by 3 is plus or minus 4/3. Last one, 6. So 1 divided by 6 is plus or minus 1/6. Then we would do what next? 2 over 6. What's 2 over 6? 1/3, yes? 4 over 6 is 2/3. And if you're going through these, and if we have a lot, just use the calculator and put them in, just to make sure, especially once we get bigger numbers. So we can say 1/6, okay, it's 1/6. 2 over 6, oh, it reduced to 2/3, we have it. So again, simple calculations. If I'm not paying full attention, I will make those errors too. I did it yesterday in the trig class. So now what we're going to do next is look at the graph and compare it to these here. So if we look at the graph, we've got spots of intersection between -1 and 0, 0 and 1, and where else? All the way up between 2 and 3. Well, we can look between 2 and 3. Are any of these rational numbers between 2 and 3? 4/3 is 1 1/3, yes? So are any of them greater than 2? And again, no. And I did this one earlier today, and I was looking at maybe I missed them, and I rechecked my possible factors, and no, that one there does not exist as a rational number. So most likely it's going to come out as irrational. So the next one we can look at is between 0 and 1. It does intersect. Is it closer to 0 or closer to 1? Or neither? It's kind of in the middle, yes? Do we have one of our possible zeros that's in the middle? Positive a half, yes? So we can try that first. Now, we can do this by synthetic division, or we can use the calculator, because we can go second trace. And the first one is value. And if we select this and say 1 divided by 2, 1/2, and hit enter, we get a y value of Yeah, we have to put it in. So we get a y value of 0. What that tells us is that 1/2 is a solution. It works. So that's helpful because when we come back over here, 6, negative 11, negative 16, 2, and 4, we know already that this number over here is going to be 0, which hopefully means that this number is going to be negative 4, because that's the only way we can get a 0. Now, if we work this through here, well, 1/2 times 6 is what? 3. Half of 6 is 3. And again, I'd be doing these in the calculator, just letting it do it for us. Negative 11 plus 3 is negative 8. That's again a nice number because half of negative 8 is 4, and it would be negative 4. Since we're dealing with a positive number, the sign won't change. Negative 16 plus negative 4 is negative 20. Half of negative 20, so we'd have negative. Half of 20 is 2 plus negative 10 is negative 8. And it's half of negative 8, negative 4? Yes, and 0. It worked. It also means, since we know that it does cross, that positive 1/2 won't work again. Because there's only 4 solutions. We saw the one way out between 2 and 3 was irrational because it doesn't show up here. So we have 2, and then we have 2 others on the other side, yes? One other thing, because we'll cover this here in a little bit, we had the complex conjugates in last chapter, yes? The complex conjugate theorem stated if A plus BI is a solution, then A minus BI is a solution. They come in pairs. It also works with irrational numbers. If I have 1, I have to have another. They always come in pairs of 2. So since we know the 1's irrational over there, that means somewhere else there's another one. So that's also why I could tell that the other side, it did cross. Because if 1's irrational, there's got to be 1 over here. Does that make sense? Okay. So we look back at this here. We found this one. So one of the points over here between negative 1 and 0 is going to be rational. So we need to look at one of these here that's close to negative 1. So what value would be close to negative 1? So we can say 1/2, because 1/2 was in the middle. We already had 1 in the middle. It may or may not look like that one. So 4/3 is too big, 1/3 too small, 1/6 is too small, so we're really left with 2/3, yes? And we can check it. So I can come over here and do second trace enter again and say negative 2 divided by 3, and we get 0. So that means negative 2/3 is going to work. We could plug these into the calculator. Negative 2/3 times 6. Well, 6 divided by 3 is 3. Negative 2 times 3 is negative 6. Let's see here. Make sure. Nope. There you go, right there. What is 6 divided by 3? And negative 2 times 2 is? Negative 8 plus negative 4. Negative 12. We do it again, so negative 2/3 times negative 12. Well, negative and negative make a. 12 divided by 3 is 4. 4 times 2 is? No, you're good.
There's that.
But there are a lot of things, once you see the easier way to do it, it makes everything work. So I divided first. Because when you multiply two fractions, you're multiplying the numerators. So we're saying negative 2 times negative 12 over 3. And when we talk about simplifying up and down, how we can cross out like terms. So we can say 12 over 3, which is negative 4, and then multiply together. Yes, but I've also done it a good bit. There's a good bit I have to write down too, because if it starts getting too many numbers, it. A lot of repetitive. So, yes. So 8 plus negative 20 is negative 12. So we're doing negative 2/3 times negative 12, yes? 8, which is 0. Now at this point here, we don't have to continue to look for other solutions for two reasons. One, we know the other two are going to be irrational. And two, the degree of what we have now is a degree 2, because we decreased the degree 1 each time. So we started out with a degree 4, did synthetic division once, took it down to degree 3, did it twice, so now we're down to a degree 2. So it could be, but it's not, we could have one where there are other rational solutions there. But once I get it down to a degree 2, unless they're nice numbers like 1, 2, they're integers, I'm going to stop here. Because what we have the quadratic formula. Because at this point here, we can plug these values into the quadratic formula, simplify, and done. I don't have to continue to search and try other solutions, especially like the one we did yesterday where we still had a good number of possible rational solutions to look for. This here will simplify it for us. Because we have two left. Because this one, there's a total of 4. So we found out that x is negative 2/3 and 1/2. Now we plug the variables back in. We'll have 6x squared minus 12x minus 12 is equal to 0. If there's a greatest common factor of a number between all three terms, let's get rid of it. So here we can divide everything by 6. And this makes it a lot easier to work with because now we're left with x squared minus 2x minus 2 is equal to 0. If the first term is negative, divide it by, or multiply everything by negative 1. Make that first term positive. Because this here makes the denominator a lot easier to work with. Because now the value of a is what? 1. A is always in front of x squared. So on the bottom of this we have 2 times 1. So negative b, our value b is negative 2. So we can say negative parentheses, negative 2, close parentheses, plus or minus, square root. So we have b squared, yes? So we could say negative 2 squared minus 4. A is 1 and c is negative 2. X is equal to 2 times 1 is 2. Negative negative 2 is positive 2. And we're going to plug this into the square root. Now, whenever we have a number inside the parentheses that's negative, when it's squared, it's going to come out what? Positive. Because negative 2 squared is going to be a positive number, yes? So, parentheses, negative 2, close parentheses squared, minus 4 times 1 times negative 2. We can hit enter. And we get 12. What's interesting with this here, we know that a negative number squared is going to become what? Positive, yes? So sometimes this is just what I normally do is sometimes I'll drop the negative in the parentheses because I know that negative 2 squared is going to be positive. So it'll be the same as 2 squared. But again, if you put it in as negative 2, you need the parentheses around it. You need the parentheses around that first negative 2. Because if you don't put those there, it will give you a completely different answer. Because what it sees that as is negative 2 times 2. It doesn't see the negative in the 2 as one term. What it sees is negative 1 times 2 squared. It sees it as negative 4, where it should be 4. Adding extra parentheses around the numbers does not change anything. It does not hurt anything. So adding extra parentheses will sometimes help. Now we can use the other calculator to see. Can we take the square root of 12? And the square root of 12 is 2 square root of 3. So the 30xs will do that for us. We don't have to do that by hand. And again, just like the last test, if you can get to at least here, that's going to be great. Do the two numbers on top and the number on bottom all divide by the same thing? They're all divisible by 2, yes? So here we can say 2 divided by 2 and 2 divided by 2. We're dividing that 2 out. You're good. So 1 plus or minus the square root of 3 is the other solutions. And we have negative 2/3 and 1/2. Any questions on this here? Message. So take a picture of the problem, email me. I'll get back with you pretty quickly, especially if you get a.
I'll just write them all through.
Yeah. And again, Wolfram Alpha, especially if you work it out and you're not sure that the answers work, Wolfram Alpha is a good place to try. Also, what we can do is even these here, 1 plus the square root of 3. So on the graphing calculator, we have it typed in, yes? I can go second trace value, 1 plus second square root 3, because that's one of our solutions, yes? Enter. And this here, that 7.8 times e to the negative 12th is essentially 0. If we get e to the negative 12th or e to that big number, it's essentially 0, because what it's saying is it's 7.8 times 10 to the negative 12th. E is 10. And if we write this out, the 0.1, 2, 3, 4, 7, 8, 9, 10, 11 is essentially what that's saying, which is really close to 0. Because again, it's using pixels on that screen, and the size of one of those pixels is about 7.8 times 10 to the negative 12th. So it's that really small rounding error. So we can actually use the calculator to help us approximate these. Questions on this here? The other one where we stored a value into x. So I could have stored this value into x and then typed it out and see, does it give me 0? Plugged it back in. Any questions on these here? So, okay. So 1 plus second square root of 3 store x. So our function was 6x to the 4th. Was it minus 11 x to the third. Then what was our next number? X squared plus 4. And we get that essentially 0. Now the reason it's throwing that up is because it's having to approximate the square root of 3, because the square root of 3 is irrational. We can't get the whole number.
What is it?
10.
Oh.
It's 10 to the negative 12. It's the calculator shorthand for that. Questions on any of these here? So I'm not going to make y'all go through another one of these, because for this one here, how many solutions would we need to find? At least 3 is what we want, because if I get 3, we're done. Those are the 3. But at least 1, because if I get 1, it takes it from a degree 3 to a degree 2. Quadratic formula, we're done. And the same for this here. If we get at least 2, especially on the test, because I will give points for each answer, because I always do give points for each answer. So if you're able to get 2 out of the 4, that's still 2 out of the 4, 2 points out of the 4. And if you get at least 2, go on and do the synthetic division with both of those. Even if it's a degree, however, and you only get 2 out of the 5 or 2 out of the 6, do the synthetic division with those, so at least you get the points for doing those, finding those. And especially if the numbers are nice numbers, if it's 1, 2, 1 or negative 2, do it. Do the synthetic division and go from there. Okay? Now, the last thing we're talking about is the irrational conjugates theorem. If a plus bi is a solution, or is a 0, so if we're saying x is equal to a plus the square root of b, well, x has to equal a minus the square root of b. Because if one of them is a solution, the other has to be a solution also. And this is the same thing if we talked about, because where we said a plus bi and a minus bi, when we dealt with those, because when we multiplied the two together, all the I terms canceled out, yes? The same thing is true if we multiply two irrational conjugates. All the square roots, all those radicals will simplify out. That's why they have to come in pairs. Questions on this here? Write a polynomial function f of least degree that has rational coefficients and a leading coefficient of 1. All of this is to say, I'll explain the first half of this a little more after we finish, but they're saying that the zeros are these here. These are the solutions to this here. So at the very end, we're saying that x is equal to 3, and x is equal to 2 plus the square root of 5. We're saying these are two solutions for this here. Okay? Well, if 2 plus the square root of 5 is a solution, it also means what? X is equal to 2 minus the square root of 5. Because if a plus the square root of b is a solution, then a minus the square root of b is a solution. If we have one, we have to have the other. Questions on this here? So when we solved, this here was the last step, getting it equal to x, yes? Essentially for these here, think about it, everything we did, especially like with factoring, what we started this section with, where we factored it down, set multiple sets of parentheses equal to 0. Had them multiplied together equals 0, set them equal to 0 and solved, yes? We're flipping that. So what we want to do first is get these equal to 0. So to get x equals 3 equals 0, well, I'm going to subtract 3 from both sides. So x minus 3 is equal to 0. We good with that one there? We'll do the same thing with the next one. So here, I can minus 2 from both sides and say x minus 2 equals the square root of 5. Well, unfortunately, this is not equal to 0, so I have to minus square root of 5 is telling us x minus 2 minus the square root of 5 is 0. And last but not least, we're going to do it with this one here. Up there. X minus 2 is equal to negative square root of 5. So now we would add square root of 5 to both sides, telling us x minus 2 plus the square root of 5 is equal to 0. Okay? Questions on anything we've done so far? So when we did this at first with factoring, well, we factored it and had multiple sets of parentheses equal 0. So one of them must be 0. We set them equal to 0, yes? And then solved. So going backwards, we kind of unsolved, got them back equal to 0. So I have 3 statements equal 0. So we can multiply them together. So we're saying that we have x minus 3 times x minus 2 minus the square root of 5 times x minus 2 according to the zero product property of multiple things. If we have multiple sets of things multiplied together that equal 0, one of them must be 0. Here we have 3 things that are equal to 0, so we can multiply them together, and they're still going to be 0. Questions on this so far? We only have one last thing. It's just multiplying these together, and we're done. Now, the order in which we multiply them really doesn't matter, but I will say, I'm going to grab a highlighter. Always do conjugates first. Always do conjugates first. Always multiply the conjugates together first. And it'll make a little bit sense here in a minute. So we're going to have x minus 3. It's going to be last. Now when we multiply the other one, x times x is x squared. X times negative 2 is negative 2x. X times square root of 5 is plus x square root of 5. So we did it with just x. Now we do it again with negative 2. Negative 2 times x is negative 2x. Negative 2 times negative 2 is plus 4. Negative 2 times square root of 5 is negative 2 square root of 5. Then we do it with negative square root of 5 times x is negative x square root of 5. Negative square root of 5 times negative 2 plus 2 square root of 5. And lastly, negative square root of 5 times square root of 5. Well, square root and square, because we'd have 5 times 5, which is 25. Square root of 25 is 5. So we just took each one and multiplied through. This is going to look a little bit nicer once we combine like terms. So if I look through here, so the first one we have is x squared. Is there any other terms with x squared? So we have x squared. Negative 2x, negative 2x, so we have negative 4x. I don't include the x square roots of 5 because, again, they're not like terms. We have to have the square root of 5 for them to be like terms. But speaking of those, here I have plus x squared of 5, yes? Here I have minus x squared of 5. That is what? X squared of 5. They are gone. That is 0. Here, negative 2 square root of 5 plus 2 square root of 5. That is 4 minus 5. negative 1. So we get this here.
Much better.
Yes, this is also why I say to do the conjugates first, because all those radicals will go away. Because all the radicals that we had are gone. We just have x squared minus 4x minus 1. And that's it. It is possible to have done x minus 3 times our x minus 2 minus the square root of 5, but it gets more complicated faster. Unless, because there's been sometimes I've tried to show that on the board, and I've somehow got terms mixed up, and it got really confusing really quick. It's easier to just do the conjugates first. So we have this here, yes? We're doing it one last time and we're done. Now with this here, I will sometimes what I call stagger step it, and it'll make sense here in a minute. So we'll do x times x squared, which is x cubed. X times negative 4x is negative 4x squared, and x times negative 1 is negative 1x. Then we'll do negative 3 times x squared, yes? Which is negative 3x squared. We can write it out over here. I'll sometimes write it underneath it, especially if I'm multiplying, instead of having x minus 3, if we had x squared plus x minus 3, had 2 quadratics, I'll stair step it out so I can keep all the terms together. We can do negative 3 times negative 4x, which is plus 12x, and negative 3 times 1 is plus 3. Add straight down. So we have x cubed minus 7x squared plus an 11x plus 3 is equal to and that's it. Questions on this here? Is this as bad as what you thought this was going to be? Now, the terminology, I said I was going to wait till the end to talk about it, because they said, and I'll scroll back down here in a minute, they said they want us to write a polynomial of least degree that has rational coefficients, a leading coefficient, and 1. So least degree and leading coefficient of 1. So, again, we said if a number is repeated, if a solution is repeated more than once, we don't normally list it. So if I added, apparently it's going to scroll, another solution of 3, we had another x minus 3. Would 3 and 1 plus, or 2 plus the square root of 5, or 2 minus the square root of 5, would that still be a solution? Yes, that's what they mean by least degree, that none of these zeros appear more than once. They're saying least degree, the smallest degree we can have of the given zeros. So we don't have these repeated terms. Leading coefficient of 1. So the leading coefficient is 1, yes? If I multiplied, that's cubed, the whole thing by 2, did I change the zeros? Did I create a new equation? Yeah, so how many different ones could I create by changing the value of a? Well, as many as there are numbers, so there's an infinite many. That's what they also mean by the leading coefficient's 1. We're talking about this here, not one like this, because there's so many that we can create using that. Does that kind of make sense? And that's all they're adding into it. But any questions on any of this here? Well, that is it. If I can borrow one of y'all's note sheets. Because I'm wanting to look at the problems. So guys, so this, wait, no, let me do this. So these are the problems for the assignment.